again, from our, given the graph, I mean, we're not always given the graph, but given the graph and given the contour plot, I can see that we have 3 critical points, so we're going to try to find them. So z sub x, taking the derivative of this with respect to x, I have a product rule to have to follow.
Sorry, silly question. On this one, those saddle points are not going to be critical points?
Oh yeah, you're right, you're right. We do have saddle points, and they're not showing up on the contour because we didn't draw enough lines. Like if we had drawn more contour lines, you'd see the little X's. But I should probably try to draw a contour map where we can see them.
Is there a little lip then, right, around that hole, is that what he's saying?
Yeah, there's a saddle right there.
Yeah, there are 2 saddle points. So,
Oh, I guess you could.
okay, so first times derivative of the second with respect to x is going to be e, and derivatives of e is itself. And then the derivative of the inside is negative 2x minus 2 to the first power. So e, and then the derivative of the inside is negative 2x minus 2. So first times derivative of the second plus the second times derivative of the first, and let's see, I get 6 times
In this landscape.
that's all in terms of with respect to x, because the other term is just y. Okay, so then zy, keep in mind that we are interested in zeros, and so I'm going to factor this from the point of view of trying to find my zeros. So notice both of those terms have e to something in it, so I'm going to factor out the e. And then both of them have an x minus 2. And both of them have a 6, actually, because there's a 3 and then times 2. So they also both have 6 that I can factor out. Because there's a times 2 here, which would multiply that 3. So factoring all of that out of both of these, the first one I'm left with x minus 2 squared plus 3y squared. And that's all, right? And then the other one, I just have a plus 1. That's what I have.
What did that mean, minus?
Well, hang on. I did maybe in front of yes, you're correct.
I'm still catching it.
Yeah, so the negative in front of the 2 ab's of.
Yeah.
Alright, so so then doing the same over here, they both have the E that can be factored out. They both have Y that can be factored out. Hey, Liam, you are always a distraction in here, so I need you to start being more polite to me.
Okay. Well,
Okay.
well, I'm sorry. I have a class right after this, and I'm falling behind in it. So that's why I've been busy.
Okay, but I'm just letting you know that, like, you're distracted. All right, and both have a 6 because 18 has 6 in it, and 3 times 2 has 6 in it. And so the b minus x minus 2, hang on, I think we need a negative in front of that also. Because I factored out the e and the 2 and the 3 and the x minus 2, but the negative 1 was still there, and the negative 1 would be multiplying the x minus 2 squared plus the 3y. And so the same thing's gonna happen here. I factor out a 6, I'm left with the x minus 2 squared plus 3y, but multiplied by negative 1, or sorry, 3y squared. And then the second term here, I factored out everything except for a 3, right? Okay, so now we have to cleverly think about what numbers are going to end up or what points will end up making both of these 0 at the same time. So I can see that the 6 and the E, they're not gonna make any zeros, so we can kind of ignore them in terms of looking for zeros. If I put 2 in for x, then it does make z sub x 0, but it doesn't necessarily make z sub y 0 unless I pair it with something that makes this one 0. So for example, if x was 2 and y was 0, okay, if I put 2 in for the x, I don't really even care what this equals. 0 times whatever is going to be 0. If I then plug 0 in for y, I don't really care what this equals. 0 times anything will equal 0. So this is a critical point. If x is 2 and y is 0, it's a critical point. But there should be other ones because we see other things going on in the graph.
Sorry, one more time. I kind of missed halfway there. Why was there only one?
Well, there isn't only one. There's more. We just haven't found it yet.
Oh, okay, sorry.
I'm just pointing out that just right away, if I put 2 in here and I put 0 in here, it's going to make both 0. So it's one of the critical
I
points.
got what you're saying.
But we know there's more because we can see other things going on.
That's why I was a little confused. I thought I
Yeah,
misunderstood.
we know there are more because we see other things going on in the graph. So what I would do is start with, okay, what if x is 2? Okay, because if x is 2, then I already know that this is 0. If x is 2, then this becomes 0, and I would then have y times negative 3y squared plus 3. Okay, I already know y being 0 is one of my zeros. So I want this to equal 0. So negative 3y squared plus 3 would have to be 0. So y would have to actually plus or minus 1, right? So minus 1 or plus 1. So those are 2 more critical values. But those are all the ones we're going to get where x is 2, because I've exhausted my options for x being 2. So now let's try y equaling 0. Okay, Okay, so let's put 0 in for y up here and see what that tells us about x values. Okay, so if we know y is 0, then the y is 0, I don't have to bother with it, so I'm just looking up at zx. Okay, I'm only looking at zx, and so I'm left with x minus 2, y is 0, so that gives me that. I know 2 makes this 0, so I can kind of ignore it. I need minus x minus 2 squared plus 1 to equal 0. So x minus 2 has to equal 1, or x minus 2 has to equal -1, so x is equal to what two options? X would be 3, or x would be 1, right? Okay, so 3 and 1. Okay, so 1 minus 2 is -1, -1 squared is 1, but minus 1, and then y was already 0, and minus 1 plus 1 is 0. Or if I plug 3 in, 3 minus 2 is 1 squared, but multiply by -1. Yeah. So how many do we have there? 5? And did we look from the graph, there should be 5? All right, there are our 5. Okay, so 2, 0 is one of them. 1, 0 is another one. 3, 0 is another one. 2, 1, and 2, -1. I'm sorry, I can line those up a little bit better. Yes?
How would we know how many critical points we have if we don't have the graph?